Hello, here is example 3 in this video. And example 3, again, is one of those that you could have like at least 3 different ways to get to the answer. So I'll just try to go over 2. So first, here, if you notice, you do have something to the power of 2, and this something has exponents of their own. So you could do the power of power rule again, which is this one of exponent raised to another exponent, so you multiply the exponents. Let's try that route first. So in order to do that, we need to have an exponent here. We need to rewrite that as an exponent of a fraction, a rational exponent. So the root of the radical is your denominator, and 3 will go on the top. So that is the exponent for the numerator. Then we have a 2 on the bottom. So from here, we do the power to a power rule, which means we're going to multiply the exponents, but there are top exponents and bottom exponents of this fraction. So we are actually going to have 3/4 times 2 over 2 times 2. On the top, we have 3/4 times 2, which we got put over 1. And when you multiply fractions, you multiply straight across. So that will give you 3 times 2, which is 6, and 4 times 1, which is 4. And 6 over 4 can simplify as 3/2. On the bottom, we have x. 2 times 2 is 4. So on the bottom, we just have 4. Now we are left with this. So this is you realizing that you are dividing the top by the bottom, and they both have the same base. So this is where you use the rule of quotient rule, which is you divide by the same base, you subtract the exponents. So what's going to happen here is that you're going to write the exponents being subtracted from each other. And now we're going to focus on subtracting these two. So 3/2 minus 4. Fraction divided by a whole number, that means we got to put another over 1 here. You cannot combine until you have common denominators. So we got to multiply this times 2. And then you have 3/2 minus 8 over 2. Then you only combine numerators, which is 3 minus 8, which is negative 5 over 2. This is the exponent only. So now we can say that we have x to the negative 5 over 2. This needs to now be simplified by rewriting with the radical. The root is 2 because that's the denominator, so we just write the square root. And then we have x, and we can either put the negative 5 in here or put it out here. I'm going to leave it out here for now. And then here we have a fraction, technically over 1. And we need it to be a fraction to get rid of this negative, because we have the negative rule where you flip. You do have the reciprocal of what you have as a base. So what's going to happen here is we're going to have 1 over square root of x to the positive 5th power. That negative has disappeared. This means that we're going to have this times itself 5 times. So if you think about it, you have 1 times 1 times 1 times 1. So 1 to the 5th power. And then on the bottom, you're going to have square root of x times square root of x times 5 times. So we're going to have square root of x 5 times. 1 times itself 5 times is 1. So that simplifies the numerator. The denominator, though, you need to think about what's happening here. If you have the square root of x times the square root of x times the square root of x 5 times, you technically can say that you have the square root of x 5 times in here. That's why this 5 can go inside or outside. So what you need to realize here is that you're finding the square root, which means groups of 2's. You have one group right here that could come out outside of the square root. Here you have another group that could come out. So that's another x. And then you have an x by itself. That one stays inside. Because on the outside you have 2 x's, you're going to say that you have x squared and then square root of x. So this is your answer. And again, this is one way of getting there. Let's try another way. So now the other way is, instead of distributing the power to power, we're going to focus on the inside. On the inside, you notice you have two x's as base. They have in common. So turn this into a fraction. You still got to rewrite this as a rational exponent of 3/4. And now, instead of distributing the 2, we're going to focus on this. We're going to subtract the exponents, because that's what the rule says. If you're dividing the same base, you subtract the exponents. So now we're going to have x 3/4 minus 2 to the second power. Here, it's the same operation and work that we did up here. 3/4, no, it's actually different. 3/2 minus 4 is a different subtraction than this one. So right here, what we're going to do is, right on the side, 3/4 minus 2. And then we need the common denominator. Right now it's over 1. We need a common denominator, so we're going to multiply times 4. And this results in 3/4 minus 8/4. 3 minus 8 is -5. So we have -5/4. X to the -5/4 to the second power. So this is where you now use the power to a power rule, similar to what we were doing on the other one. So here we multiply the exponents of -5/4 times 2. So 2 is over 1, and multiply straight across. -5 times 2 is -10. 4 times 1 is 4. And then -10 divided by 4 simplifies to -5/2. So I'm going to write that here, -5/2. I just want to point out that that's also what we had up here, right here. So we technically have gone different routes, but we ended up in the same part of the process here. And you can either do this the same way I did it here, or you can do it a different way as well. We can get rid of the negative first, which means this x over 1 is 1 over x now. And then it's to the 5/2 power. And then this part of 5/2 is dividing 5 divided by 2. How many times does the 2 go into the 5? So that goes 2 times. We're going to do x 2 times. There's 2 2's in there 2 times, and then there's 1 left over. So you end up with the square root of x. So it's still the same answer that we had up here. It's just a different route. Hopefully this video helps you.